Welcome to the Bentley Systems training course to learn how to design gravity steel beams in the RAM Structural System RAM Steel Beam Design Module. Over the next series of videos, you'll learn how to design some gravity steel beams, which will include the process of entering the gravity beam design criteria, assigning any deflection criteria, and then designing the gravity beams and reviewing the results. After you specify all of your criteria in the RAM Steel Beam Design module, you are ready to design all the gravity members in the model. The RAM Steel Beam Design module performs an analysis and design on all of the gravity steel beams and joists in the model based on the user-selected design code and criteria. Steel beam sizes are selected from the Steel Beam Design table that is chosen in the RAM Manager. When you invoke the Design All command, this will be used to size all beams which have not been previously sized by the Beam Design module. When you are ready to perform a design in the RAM Steel Beam Design module, you will go up to your toolbar and click on the Design All icon to design all unsized gravity beams in the model. In this particular model, we have gravity steel beams on the third floor and the roof layout, so we will focus our attention in these areas. After we perform a design, we can review the results on screen by using a variety of the icons in the toolbar, and we'll select the second icon to show the designs on screen. Here we can see that all beams have been assigned a size. We can see the size indicated. If they are composite beam, we will see the number of studs in a uniform distribution placed in parentheses, and if the beam is designed to be cambered, we will also see the camber indicated. We can see some similar information up on the roof layout as well. After performing the design, we can review or modify the results on a beam-by-beam basis using our View Update commands. For this exercise, we'll review one of the beams on the third floor layout between grid lines E.5 and G. To invoke the View Update command, we will go up to our toolbar and click on the View Update icon. When we select this icon, you will notice that your cursor will change to our target icon, and then we can go ahead and select whichever beam in the model we wish to investigate. Here I'm going to select the beam just north of grid line 3. From the View Update Beam dialog, we can inspect the size of the beam and the stud configuration that was determined through the optimization. We can view the full output results file. We can view the loading diagram on the beam. We can view and print the shear, moment, and deflection diagrams. We can modify the beam size, shape, stud configuration, yield strength, or composite flag. We can modify the design and configuration of web openings, and we can save any of these modifications to the database. To view the loading diagram, we will go to our View Update Beam dialog and click on the View Loads button. Here we can see all of the superimposed load that's been applied to this member in addition to the self-weight of the member. And here we can see an evenly distributed uniform load has been applied. We can see the values for both dead load and live load, and then also the maximum total uniform load. Once you have finished reviewing the load diagram, we can click the X to exit and return to the View Update Beam dialog. If you would like to view the shear, moment, and deflection diagrams for this particular member, we can click on the View Diagrams button. Here we can see the shear diagram, the moment diagram, and the deflection diagram according to one of the load combinations, and for this particular exercise we are using LRFD. We can also use our cursor on the screen to get the exact moment, shear, or deflection at any point along this member. This page can also be printed for your records by clicking on the Print button. Once you have done reviewing the diagrams, we can go ahead and click on the Cancel button, which will bring us right back to the View Update Beam dialog. To view the beam design results report for this particular member, we can also click on the View Results button. Here we'll see all of the pertinent information for the gravity beam design, including all of our composite properties, the loading on the model, we can get our reactions, and also some information on our web openings. Once you have finished reviewing the beam design report, we can click the X button to return to the View Update Beam dialog. We can also modify the beam size, the section, the composite information, the yield strength, stud configuration, and also the web opening data for each individual member. For this exercise, we will be modifying the web opening size and then re-optimizing the member. Here, to modify the web opening data, I'm going to go ahead and click on the Modify button. And here I can modify any of the parameters for this particular web opening that was created in the RAM modeler. For this exercise, I'm going to increase the size of the web opening on this member and then re-optimize it. I'm going to enter a height of 14 inches and a base of 12 inches and then click on the Change button. Now you're going to notice that the pass or fail flag is now been taken away because we need to re-optimize this member after any changes occur. After we change our web opening information, we will go ahead and click OK. And now we're ready to re-optimize the member. Now an 18 by 35 is probably no longer deep enough to support this size of opening. So we'll go ahead and click on the Optimize button, and you can see now that RAM Steel Beam has determined that a W21 by 44 should satisfy this new sized web opening. Now if we have finished modifying this particular member, we could just click Update Database to close out of the View Update Beam dialog. If, however, we would like to go ahead and officially assign a W21 by 44 to this particular member, we can do that also through this View Update Beam dialog. To officially assign a size to any member in the model through the View Update Beam dialog, we will highlight the particular size we want to assign, say for this example a W21 by 44, and then click on the Analyze button. This will instruct RAM Steel Beam that you want to force the design to be a W21 by 44. After you click the Analyze button, the Update Database button is now available, and we will go ahead and click on this button now. A warning dialog will pop up saying that this size and stud configuration will now be officially attached to this beam, and when you reperform a new optimization on the model, the W21 by 44 will still be assigned. We will go ahead and acknowledge this warning and then click OK. This W21 by 44 is now officially attached to this member. At a later date, if some information such as your model loading were to change and you were to redesign these gravity members in the RAM Steel Beam design module, this size will not be overridden by the optimization process. You will be given a warning, however, that this member fails if it does not satisfy all the code check requirements based on any changes that do occur. To reperform a design, you can do this at any point, and we'll just again click on our Design All icon. In addition to using the View Update tool, we also have several design reports available from the RAM Steel Beam design module. All of the reports available are available through the Reports main menu item. For this particular exercise, we review a couple of reports available here. In the Reports menu, we'll select the Summary option. In the Beam Summary Report, you will be given a variety of information on each gravity beam in the model, including the length, the capacity, and the ultimate loading on that particular member, and the beam size that was determined. After reviewing the Beam Summary Report, we will go ahead and close out of it. In addition, we also have a framing check report, also available from our Reports menu. In the framing check report, RAM steel beam will report any location where a beam is deeper than the girder supporting it. This will not force a larger girder to be assigned to the particular member, but this is available so that we can view these situations to see if there are any girder sizes that maybe you'd like to deepen to satisfy this type of criteria if you're concerned about maybe some of your connections. After reviewing the beam framing check report, we will go ahead and click on an X, and then we will save our model. After you are done designing all of your gravity beams in your model, you can close out of the RAM steel beam design module by clicking on File Exit. This will bring you back to the RAM Manager, and you are ready to move on to the next phase in your design process, which for this sample building, which would be to design your gravity steel columns.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.